Hi everyone, I'm May Xin. Here are the group members from Group 9, and in this video we will talk about DC series motor. Let's start with the basic construction. DC series motor is one of the type of DC motor that convert electrical energy into mechanical energy by creating magnetic field that is powered by direct current. Field winding and armature winding are two windings that make up the DC motor as shown in this figure. Armature winding will revolve, but field winding is motionless.
I will introduce for DC series motor constructions. It is built in such a way that the field winding is in series with the armatures, thus a higher current pass through it and same current flow in the field and the armature winding. This arrangement aids in the production of huge amount of torque.
The power supply is connected at one end of the armature and field coils in DC series motor. When the voltage is supplied, there will be a minimal resistance since the conductors in the windings are huge, and this will lead the motor to get a huge supply of power from the terminals. As a result, a strong magnetic field is produced due to a large current flow in the armature, and the field coils will create a massive torque in the shafts. This huge amount of torque will spin the armature and thus produce the required mechanical energy. Apart from that, DC series motor have their own flow and their speed is very much dependent on the load. When the heavier the load is, the lower the speed of the motor's armature will be and vice versa. Therefore, the motor will operate very fast and the armature might fall into pieces if the load is removed completely. The speed control of DC series motor can be attained by using flux control method and armature resistance control method. The method which is used most frequently is the flux control method. This is because the flux generated by the motors can be changed using this method, and the difference of the flux can be determined using field diverters, armature diverters, and tape field control. For the armature resistor method, a variable resistor can be connected directly in series through the supply. This can reduce the voltage across the armature and also the speed drop. By altering the value of resistance, any speed under the regular speed can be attained, and both of these methods are the most general method used to control the DC series motor speed.
So moving on to the next one is the characteristic of the DC series motor. So the first characteristic is a speed and torque characteristic, and this is also known as the mechanical characteristic. So the speed sharply falls with the increase in torque and for small values of load, but at a higher load, the speed drops linearly but slowly with increasing torque. So the second one is the torque and current characteristic. So for this characteristic is also known as electrical characteristic, and for this characteristic we know that TA, which is the torque, is directly proportional to the flux, and IA, but as we know in DC series motor, field winding is connected in series with the armature current. Therefore, a series motor exerts a torque proportional to the square of armature current, which results in a graph like this. So the third one is the speed and current characteristic. So for this characteristic, for small load current, the change in back EMF is very small and we can neglect it. Hence, for a small current, the speed is inversely proportional to the flux, and as we know, flux is directly proportional to IA. Thus, the speed is inversely proportional to IA. Therefore, when armature current is very small, the speed becomes dangerously high, and that is why we never start the series motor without some mechanical load. Thank you.
I will explain about the application of DC series motor. DC series motor is suitable for both high and low power drives, for fixed and variable speed electric drives. DC series motor are used where high starting torque is required. These motors are only used where the variation of speed is possible. Therefore, series motors are not suitable for constant speed applications.
DC series motor is easy to assemble and it has high starting torque. Also, this type of motor has simple construction and it is easy for design. It is cost effective and easier for maintenance. DC series motor can produce enormous rotating force or torque from its inactive state. Because of this feature, this motor is suitable for mobile electric equipment, tiny electrical appliances, and automotive applications such as vacuum cleaner, air compressor, traction system, cranes, sewing machine, and air dryer.